Let us now do part C, which is the last part in example 2. Part C has given us the function s equals to 2t cubed. Now, what is the formula when we are differentiating from first principles? The formula generally says dy dx equals to limit as h tends to 0 for the function f of x plus h minus the function f of x all over h. That is what the general function states. Now, what do? We say, if you look at this function, it is in terms of s. So we say let s be equals to the function f of t. Why are we putting t here? Because the function s is defined in terms of t. That means s is a function in terms of t, which is the function ft. So therefore, f of t becomes 2t cubed. That is f of t. Now, what about now the function? Okay, the function f of t plus h. What is the difference here? The difference here is that instead of x here, instead of x cubed, it is t cubed. So where we find x is where we shall put t. Like here, this one later will be t, this one will be minus f of t, simply in that manner. So instead of saying f of x plus h, instead of saying f of x plus h, we are saying f of t plus h equals to, now we shall use the function f of t, and where we find t, we shall put t plus h. So here we shall have 2 into, this is t. So instead of this t here, we are putting t plus h, and then we cube it, is to power 3. Now we need to expand this using any of the method. One, you can operate brackets, you can use Pascal's triangle, also called addition triangle, and then 3, you can use binomial expansion, binomial expansion. But for now, let me operate the brackets. This means that it is 2 into t plus h times itself again t plus h times itself again t plus h 3 times. 1, 2, 3. Now let us expand. So let me start by expanding these two first. So I'm going to keep these two constant. I will have 2 into t times t squared, t times h, th plus t times h again. So here we shall have 2 th plus h squared. This expansion is not our focus here. If you don't know how to expand, you can go to S.4 Mathematics and you find a list of videos there. Then times t plus h. Now we need to multiply this by that now. So let me expand, let me extend my equal sign here. So my f of t plus h equals to, I'm going to keep that to there, t squared times t, I will have t cubed, t squared times h, I will have t square h. 2th times t, I will have plus 2t squared h. 2th times h, I will have plus 2t h squared. H squared times t, I will have t h squared. H squared times h, I will have h cubed, or h power 3. Close the brackets. Now from here, let us combine the like terms. So we still therefore f of t plus h equals to 2, we have 2 outside there, into t cube is alone, Also here t cube. What about t squared h? There is this plus 2. I will have 3 t squared h. Yes, so plus 3 t squared h. And then I've used this. And then 2th squared. There is one here. There's another one here. So I'll have 3th squared. Because this is 2, this is 1. And then finally have h cubed here plus h cubed. So let us multiply through by 2. If we multiply all the terms in the bracket by 2, we shall have 2t cubed plus 6t squared h plus 6t h squared plus 2h cubed. So this is the value of f of t plus h. That is the function f of t plus h. The formula requires us to find the difference between f of t plus h and f of t only. So let us subtract. Therefore, f of t plus h minus f of t equals to, we substitute for f of t and f of t plus h. So f of t plus h is 2t cubed plus 6t squared h plus 6t h squared plus 2h cubed minus f of t is 2t cubed. So this 2t cubed and this 2t cubed here are cancelling out. That leaves us with 6t squared h plus 6t h squared plus 2h cubed. This is now the difference which the numerator of the formula needs. Therefore, we shall say dy dx equals to, our markers, equals to limit as h tends to 0 for the function. Now, the difference of the two terms of the numerator is already there, which is 6t squared h plus 6t h squared plus 2h cubed. But the formula says we divide that difference by h. We divide the difference by h. So, if we divide each of the terms by h, we shall have limit as h tends to 0 for the function. If we divide the first term by h, we shall have 6t squared plus 6th plus 2h squared. That is after dividing each of the terms by h. Now, from here, what do? We consider this implication of h tends to 0. So in this expression here, we need to substitute for h as 0. That now gives us our answer. Dy dx becomes, now you leave out this part of limit and then it takes effect in the expression. So we shall have here 6t squared plus 6t times h. H has occurred here, which is 0, plus 2h has occurred by h squared. That means there, this term is 0, this term here becomes 0. It gives us here 6t squared as our answer. So that is the solution to part C when we are applying the principle of, when we are applying the first principles. What have you noticed? You have noticed that here our function is again saying dy dx. But remember, our function was s. Okay? Our function was s. So instead here we shall have ds dt. Please, this is now going to be ds dt because the function is s in terms of t. So this is ds dt. Please change that if you noticed it earlier. Thank you. And then you come to your check. Remember you're given S equals to 2t cube. Let us differentiate applying the concept of powers and coefficients. That means we shall have ds dt equals to, we lower the power. So we shall have 2 times 3 t power 3 minus 1. This gives us here 2 times 3 is 6 t squared. Thus, you can go away very sure that you have passed that number. But if the video answers are different, try to cross check.